All right, so we are now ready to start talking about friction. Okay, so this will be the last force that we study in this chapter, and then we'll combine everything together. So let us understand what's going on. So let's say that there is a block sitting on top of a surface. Okay, now when nothing is going on, okay, we know that we have the force of contact between the surface and the block, and we have the force of gravity. So we know the contact force, the normal force pushes it up. We know gravity pushes the block down. Okay, and nothing's happening, nothing's moving. So in this case, what we understand is that there's no reason for there to be any friction. Okay, now let us say that we start to push this block, and say we exert a force of say around 5 newtons. Okay, and what we notice is that this block does not go anywhere. Okay, so what conclusion can we draw from this? How much friction do we feel? Okay, and the answer to this question is that when you exert a force of 5 newtons and the block is not going anywhere, the amount of friction is simply equal to 5 newtons. Okay, now if we have tried to push it to the right, the force of friction will end up being to the left, and it will be in the amount of 5 newtons. Okay, that's all that is required. Now, if on the other hand we increase the 5 newtons to 10 newtons and we observe the same thing happening, that the block is not moving, then we know that the force of friction in that case will end up being 10 newtons. Okay, now the important thing to keep in mind here is that the object is not moving, it is static. And in the static case, what we actually observe is that the force of friction increases. Okay, it increases from 0 to some maximum value. So what we know is that in the static case, okay, the force of friction goes from 0 to some maximum value. Okay, now when the force pushing the block is just above this maximum value, the block will now start to slide, and once it starts sliding, what we know is that the friction that you feel, okay, which is the kinetic friction, it ends up remaining the same amount. So for a surface, the kinetic friction is fixed. However, the force of static friction will go from 0 to some maximum value. So once again, when the force applied is greater than this maximum value, okay, the object will move, the block will slide. Okay, and once it slides, we have the kinetic case. Okay, and here the force of friction is a fixed value. It's fixed for any surface. So it's important to understand this, and it's important to keep this in mind. Okay. Now, if we were to draw a graph of the applied force to the force of friction, this graph would look like this. So if this is the force applied, and on the y-axis we have the force of friction. Okay. So what we know is as you increase the applied force, the force of friction also increases, and it happens until a particular value, which is the maximum value, which we call Fs max, which represents the static force of friction and the maximum value of the force of static friction. So this is Fs max. Now beyond this point, the object now starts to slide, and when it starts to slide, the force of friction that we feel is less than this Fs max, and this is equal to Fk. And no matter how much you increase the applied force by, once it starts to slide on that surface, the force of friction is fixed, and it has a value of Fk. Okay? Now, having said all this, we can ask the question, what is the force of friction dependent on? And if you look at, if you do a simple experiment, like take a chair and push the chair, and have someone sit on the chair and do it again, will it be easier? Will it be harder? Okay? So that should answer your question. That the force of friction is going to be dependent on the force of contact. Okay, so what we know is that friction is proportional to Fn, and you may have understood already from our earlier discussion that it also depends on the material. Okay, so when we combine all these things, Okay, what we have a simple equation. We have Fs max, which is the maximum force of static friction, is equal to a constant mu s multiplied by Fn. Now mu here is a Greek letter, it is read as mu, and mu sub s Fn, and I'll tell you what mu s is. Okay, mu s is the coefficient of static friction. Okay, and Fs max is the maximum force of static friction that we feel. Similarly, we have an equation for the kinetic friction, which is equal to mu k times Fn, and mu k is equal to the coefficient of kinetic friction. Okay, so we have our force of static friction, okay, that goes from 0 all the way to mu s Fn, and then we also have our force of kinetic friction. Okay, so there are two kinds of frictions, static as well as kinetic, and the static we know goes all the way from 0 to Fs max, which is mu s Fn, and the kinetic goes from kinetic is always fixed for any particular surface. Now, at the reason friction itself exists is because there are these very weak bonds that are formed between objects that are in contact with each other. And when you're trying to move an object, okay, you have to break these bonds. Okay, and what we also understand is that these bonds are the strongest when an object is at rest, okay, and it's weaker when the object is sliding, and that is also the reason why the force of kinetic friction is less than the force of static friction. All right, so what we need to understand is that the force of friction depends on the force of contact. Static friction changes from 0 to a maximum value called Fs max. Kinetic friction remains fixed for a particular surface, and we know how to calculate each one of these things. Okay, and to find the maximum force of static friction, we need the coefficient of static friction, and you multiply it by the contact force. And to find the force of kinetic friction, we take the coefficient of kinetic friction and multiply it by the contact force. In the next video, we will solve problems related to all these things.